Yeah, we are live. We can start.
Sure. Okay. Hey everyone. Today Shobit and Hardik will be kind of presenting what Antigranular is, and we are working with CodePeak, and we have released two repos in which we'll be discussing about the two phases that we have put up. So in the first phase, we have the Harvard OpenDB hackathon, and in the second phase, you'll be working on two repositories that Hardik will be later discussing with you guys. But as a starting point, what we want to come up with is to give you a fair idea about what antigranular is, what it does, and how you can navigate through it, work with some data sets, and get along in working with the phase one of the competition. So let's get started. As I say, Antigranular is like a community platform which has like a really solid commitment to privacy enhancing technologies. So what exactly is a privacy enhancing technology? It's basically any technology that works on maintaining strong privacy guarantees for all individual in a data set. Let's take a scenario. You can consider like, for example, you go to any local branch of your bank account. The bank just needs your customer ID and they can just see all of your bank statements, all of your transactions. Whereas the only thing they needed was like maybe some statistic. But there are a lot of transactions that to whom you have given what transaction, which is not actually the main necessity for the person, but it's revealed to anyone who has your customer ID in the bank, which is a major privacy leak. Similar to that, there are various other scenarios where individual privacy is compromised uh, within the company and where any data analysis takes place. So what we are trying to do is come up with a platform where data analysts can do data science without actually seeing the records. Like they would not be able to see the individual records. However, they would be able to get useful information from it. So such a tool that allows us to do this is called as differential privacy, and that's what we work on. So before that, I'll just give you a brief overview of the website. So this is a homepage, and all the competitions take place here. So for the phase one, what you need to do is you need to participate in Harvard OpenDP hackathon. But I would strongly suggest you to try out the sandbox for Harvard OpenDP before you jump into Harvard OpenDP hackathon. The sandbox is just for you to try and test out things. So based on this, you would be getting 50 points multiplied by the score you get in Harvard DPO hackathon, which will be added to the code pick. And for the phase two, Hardik will discuss it later. Similarly, there are other data sets too that you can try out. And there's a section for notebooks where you can look on to the notebooks that other users have submitted to gain valuable insights about each library. In case you have like any doubts or any queries that you want to clarify, there is our Discord channel that you can go to, and we are all ears all the time. In case you need to go through any API reference or any specific detail about a specific library, you can go to the Antigranular docs, which contains like an in-depth guide about the use case, implementation, and examples for each library that we currently offer in Antigranular. Just give me a sec. Okay. So as I was saying, Antigranular, we use two primary tools. One is confidential computing and differential privacy. So I'll be focusing more on the differential privacy side because that's where our current phase two repos focus on. So you can consider differential privacy as a framework for formalizing privacy guarantee. So whenever an information is kind of released from a data, uh, there is a budget that needs to be associated. So I'll just walk you through a notebook, which explains like how the different like epsilon varies with the accuracy. So let's get into what epsilon basically is. So if you get into the Antigranular code peak wiki that's been shared in Discord, you can go to fundamentals of differential privacy, where you can learn about what exactly differential privacy is in a crux, not in a very mathematical way, but in the necessary way in which you can work with our repositories. So you can just go to the epsilon delta differential privacy section, where you have like a brief guide about what epsilon and delta is. So you can consider epsilon like a budget, which you associate to get some information. And it basically, for example, if you spend a low epsilon, you can say that your result will not have a large accuracy. But if you're spending a large amount of epsilon, that means you get a more accurate result out of it. So in mathematical terms, you can consider it as the probability in which you can figure out if an individual is there in the data set or not. But with respect to the usage terms, you can consider epsilon as like a price that you pay. So you pay higher epsilon, then you get a higher accurate result. And delta is not something that we need to focus for the repository, but it can be assumed in a manner in which it's like an additional cost that might be needed in case, like, for example, if I say that there is a probability of epsilon that your data set is isolated, or like it's not compromised, then there is a delta chance that it might have not worked as expected. So the delta is just a normalization cost that we add onto it. So you can go on to the sample examples which we have written, and it's in a very easy to understand go. But one thing that would be needed is how, well, let's say we can visual. There's a notebook we can use to visualize how epsilon actually affects with the accuracy of our data. So in Antigranular notebooks, you can just move on to, just give me a second. I'll just find the notebook. Okay, yeah. So understanding performance over epsilon values. So you can just launch this notebook in a Google Colab or download it as an IPM file as you wish. But I'll just go with the Google Colab launching. It'll just show you how you can sign up and stuff like that. So first thing you need is you can just install Antigranular. Install. And meanwhile, if you see the second code block, you can see that it's kind of hidden, like the client ID and client secret. That's something that you have to get once you log into the Antigranular. So all you need to go is click here, sandbox competition, and you will have like a code snippet on the top right section, and you can just copy it. It'll automatically copy your client ID and client secret code, which you can just paste. And once you have logged in, you will have a session which connects to Antigranular. Okay. So I want to just executing every code block in this. I'll just give you a brief walkthrough of what's happening and how epsilon affects the accuracy of the result that you get. So first thing to note is any code that you write in Antigranular should be inside the percentage AG magic block. So how this works is any code written without percentage AG is run locally in your system, but any code written behind percentage AG is run in our isolated system where you cannot easily obtain the record level access of the data. So for example, for you to be able to get OP pandas, you should be executing the code in percentage AG. You cannot run OP pandas locally. So in the first example, I was just visualizing the privacy utility trade-off. So as you see, you can say how epsilon varies with the percentage error. So as you increase the epsilon, the percentage error of your result decreases. And you can tweak in the code that's given in the notebook to work around how things work. But the basic idea is that giving a large epsilon gives a smaller error. But you can ask the question to me that why not spend a lot of epsilon every time? The catch is that there is a limit generally when you do data analysis on a very secure data like a census data. There is a budget that is associated that you cannot use epsilon an amount more than this. There is a max cap. So for example, if the privacy budget of that data is 10, then the accumulated cost of epsilon that you use should not exceed 10. So you need to use epsilon in such a way that you get considerable amount of accuracy, but you will use less epsilon. So there is an extra trade-off that comes here. Similar to that, there is another trend, which is the epsilon affects different mechanisms. So sum and mean are very unit mechanisms in differential privacy, but median is a mechanism which internally uses uh, the mean, due to which there are multiple operations taking place in median compared to the sum and mean. So that's the reason why the percentage error is different for median compared to sum or mean for the same amount of epsilon. And if you use more complex operations like covariance or correlation, then the percentage error is will be tending to more. So these plots are just for giving you an fair idea of how much amount of epsilon one needs to use. Similarly, epsilon also affects on sensitivity or the sensitivity, as well as epsilon also affects on the data set size. So this is something which is very important. So for large data sets, you only need to spend a very small amount of epsilon. Because if you think in that terms that in a large data set, finding one individual is way harder than in a small data set. Let's say there are 10 people, it's easier to find one guy with some information. But if there are like 1 million people in the data set, finding one guy from that data set is going to be tough. So this is a trend of how the epsilon will affect with respect to the data set size. For more in-depth idea about how differential privacy works, I think you can go through the code peef wiki that we have shared with you, and that will give you a very fair idea about what differential privacy is. And you can also go through the data analysis using private pandas, which will give you a glimpse on how our differentially private version of pandas, which is OP pandas, works. So Hardik will be carrying forward with ideas about phase two and how you should go along with working with OP pandas.
Thanks, Shubhat. I'll just share my screen right now. Just a second. By the way, do you guys have any questions? Because we can't see like where the questions are coming out. Aryan, can you help us with that? I guess silence means there are no questions. So let's just move ahead. So I'm Hardik. I'm a senior software engineer at AWS. I'm working on building Antigranular. And today I'll be showing you how OP Pandas works, a little bit glimpse into OP Pandas and what the track 2 basically is, what the two repos are, and how you can contribute to our two open source repos. So for the first one, I've just created a tutorial notebook. I'll be sharing the link with you through Discord, and I'll just be going through it cell by cell and teaching you how OP Pandas works. OP Pandas is basically just a uh, private version of Pandas. So there are two types of frames: private data frame and private series. So in private data frame and private series, they're just like normal pandas data frame and data series, but you can't look at the data directly. You'll have to make queries using differential privacy, which Shobit just discussed, to get the final statistic result. So to work with Antigranular, basically first you have to install Antigranular using pip. It's pretty simple. Just use pip install Antigranular, and then you'll have to log into the competition. I've just logged into the Harvard OpenDB hackathon, which will be participating in um, using the credentials in the anti-granular site. So here you can see that the two data sets are already loaded for you within the AG environment. So the name of these are flight company dataset and health organization dataset. So you can just put them in a variable. Both of these will be a private data frame. So it will be like a data frame, but you can't look at the individual record level information. The next thing you can do is check the privacy budget. So as Shobit explained, you get a budget which you can spend. Right now, we have spent zero epsilon and zero delta because I haven't made any queries on these two data sets. So that's why it's showing zero. But you can check these. This will be used to create the final score, which is given here. So here, as you can see, there is some score. The epsilon and delta used will be used to compute the final score. Next, we can get some information about the data, like the columns, the metadata, and the D types. So there's two things to note here. One, that there is a metadata field. Metadata basically just means the metadata or the bounds for numerical data. There's also another type of metadata, which is categorical metadata. It won't be much useful for this competition, but you can go through the group by tutorial, which is present in the Antigranular site, to know more about that. So if you can use AG print, which is the specialized version of print within the AG environment to print variables. So here you can see the columns, the metadata, and the D types. So D type object means it's a string or something like that. You can do the same for health. There are two data sets in this competition, flight and health data. So the next is data pre-processing. I'll just be importing external data for all the tasks ahead. So I'll be just be creating a age and a salary data frame using pandas, and I'll just be importing to the anti-granular system using private import. Yeah, you can keep this in mind. Now, as the data frame is imported into the anti-granular server, you can just make a private data frame out of it using oppandas or private data frame, and you have to put in a metadata for it, else it won't consider those columns to be numerical, and you can't do statistics over them. You can also use describe and all such functions within pandas like describe, sum, and all of that. These are basic statistics which you can do, and you can print it using AgPrint to see how the data frame looks like. And here, as you can note that I've used epsilon is equal to 1. Shobit explained what epsilon and delta is. So for every statistical query, you'll have to send some epsilon. And once you use up that epsilon, it will be noted in your privacy budget. You can also visualize the data using histograms and any other plotting mechanism you would like. You just have to export the data using export, which is also present within Antigranular. And you can like here you can see that I have exported histogram data and then just sorted it using matplotlib. The next thing is you can also split the data. These are just some basic functions which I'm showing you. To get the full API reference, you can go to the docs, Antigranular docs, and just go here, the pandas API reference. So mostly for Harvard OpenDB competition, we'll be using three libraries, three or four. One is OP Pandas, of course, because you need private data from private series. Next is OP Differlib if you want to train some models. And next is Spilling or record linkage. These both are used for fuzzy record linking and all of that. So you can go through the docs in the Pandas in these docs. Here is a Spilling doc, record linkage doc, and the Pandas doc. You can also use map and apply map. Just a couple of things to note in map and apply map because a lot of users get confused here. That you need to put in type annotations for every function, and the function must be complete. Like you can't just put in if and no else statement and hope that the function will run. It has to be complete. This is done to preserve privacy of the records, and you can just terminate the session after you're done working. So now that that's out of the picture, we can just go through the repos and what the open source libraries look like. So basically, we have two open source libraries. One is the Differentially Private SKLearn, and other is Antigranular Suggestion CLI tool. So I'll just be going over what briefly what the repositories look like. And if you have any doubts, you can obviously post it to Discord or and mail it to us, and then we'll just look into it. So AG sklearn is basically a differentially private sklearn, which is built on top of scikit-learn. So this is based on Differlib, which is developed by IBM Research. And in this repository, basically we have to improve it in some sense. So improve the tools, improve the accountant. Accountant is basically the uh, thing used to manage the epsilon and delta privacy budget. So all of the issues will be present in the issues tab, and there are multiple issues. You'll be getting the points on the basis of CodePeak's point, like it's maybe 2 for easy, 4 for medium, and 6 for hard, something like that. So you'll be getting points on the basis of that, and we'll just be going through all the pull requests you give us, and hope to see you contribute in this one. And the next is AG Suggest. AG Suggest basically contains three phases of works you have to do. So for the first one, we have procured through a survey a multiple number of functions that people use in their notebook to do their data analysis tasks. So for this one, you'll be given that data in the form of a database, and you'll just have to analyze it and scrape anti-granular docs to find where anti-granular functions lack, like what functions we don't support and all of that. And for that, you'll be developing a CLI tool. So all of these three phases will be present in the issues. These three are hard, so you'll be getting a little bit more extra points for those. And the combination of these three things, like the two repos and the phase one, will give you your total points. So I'll just tell you what the point structure is. For the first phase, whatever accuracy you get, you can see the accuracy in the anti-granular side. So here, whatever score you get, this will be multiplied by 50. Then whatever issues you submit, the score will be calculated for that and added on to this. And plus, there are some bonus points up to 5 for each notebook you submit. So if you get a really nice idea or find something really nice in Antigranular, you can just submit a notebook here, and uh, you'll be getting extra points for that. So yeah, hopefully we answer most of your doubts. And if you have any other doubt, please let us know through Discord. So that's it from my side.